Hello, I'm JW. This time I'm going to have a look at lighting circuits, and this will actually be in several parts, and it's not because lighting is particularly complicated, it's just there's a number of different ways that it can be actually installed. So rather than making a massive long video of over an hour, this will be in a number of parts. And in this part we're going to have a look at the basic layout of a lighting circuit. And again, this is for the UK, so obviously it may not be applicable to other countries, but obviously the principles are going to be similar. And lighting circuits, as I say, are fairly straightforward things, but of course there is that additional part of having switches involved, which does seem to cause a bit of issue with some people. Now, lighting circuits are actually fairly straightforward, but unfortunately they are the one which seems to cause a certain amount of trouble, particularly when people go to, say, some DIY shed, buy some expensive light fitting, and then get home and rip down the existing light fitting, only to then discover that there's far more wires than they actually imagined there should be there. And of course they didn't bother to make note of where they were connected, so now they're completely stuffed and it's getting dark. And then they either resort to not having any light, or just shoving wires into holes randomly and wondering why fuses and circuit breakers are popping off all over the place, and half the lights in the rest of the house aren't working anymore. So the key thing with lighting is to identify the wires and things before you're going to rip anything down, and actually understand what they're actually for, and then of course it all becomes fairly clear. Now, lighting circuits are radials, and of course we saw radials in a previous video, so essentially you've got your consumer unit here, and then the cables will come out of that and go to one or more items. And typically in a house you're going to have more than one light, so presumably going to have several things involved there. So let's just put a typical light here, and we'll put another one over here as well. Now, in the simplest circumstance, your cable would come from the consumer unit, and it would go into the first light fitting, and then from the first one it would continue on to the second one over there. And of course you could continue on to a third and fourth and so on to the rest of the building, and that's pretty much the same as you would have, say, with socket outlets or whatever. But unfortunately there's a fundamental problem here, because if you just had this arrangement here, then these lights are going to be on permanently, lighting up the room and whatever. But of course that's useless because you've got no way of controlling them, and if you switched off here, of course, at the consumer unit, then all the lights go off in the whole house, and of course they all come on again when you switch it on. So that's fairly useless, and obviously not how lights are generally wired. So let's just draw that again, and this time see how it's actually done in practice. So here's our consumer unit here, and in our first light fitting we're going to draw this considerably bigger. And this might be a ceiling rose, as in the thing that's on the ceiling of each room with the wire hanging down. And the wires from the consumer unit are going to come out, and we're going to have a line coming out of here into the light there. And we're going to have the neutral as well coming out. And naturally we're going to have the earth as well. And those go into the light fitting in here. Now, you could just connect the actual light bulb or lamp between the line and neutral there, and that would result in the thing being turned on permanently. But of course that's not what we want, so we need some kind of other mechanism here. So we'll just draw in the light bulb down here. And this might be some old type with the coily filament inside. And it's going to have the two wires coming out, so we'll draw the neutral in. That'll just go straight into the filament. And the line, of course, will go onto the other side of that. Now, light holders in the UK are typically made of plastic, and this is just a 2-core flex. So although the earth connection is here in the light fitting, generally it's not actually connected to the lamp holder itself, unless it was made of metal or be a fairly unusual type, but earth is always taken to the actual rose itself. Now, if we connected these two together, then the light would be on 100% of the time, and there'd be no way of controlling it. So obviously we need some kind of a switch. So we'll put a switch in over here. And a switch is a device which has two positions, off and on. And when it's in the on position, two contacts inside are connected together. So it's got two terminals. So here's one, here's another one. And between them is some kind of moving part. So this is in the off position, so the two things are not connected. And when it was in the on position, those two will basically be connected together, so that would simply move across to the on position. And in order to connect it to the light fitting here, then we need some cable. So what happens is we have a cable from here, and it goes up into the light fitting, and we can join that to the one that goes to the actual light bulb itself. and the other one from here as well. And again, it'll be part of the same cable there. We can join that one onto the mains wire that comes in. And typically you would have the earth wire going down there as well. That would be connected to the metal frame of the switch if it's metal, or just parked in the back of the box if it was a plastic one. So now what we have then is the neutral here is actually connected permanently right through to the light bulb there, but the line coming in with the power actually comes through, goes to the ceiling rose first, but then is diverted over to the light switch over here. And then if the light switches happen to be in the on position, so these two are connected together, then power can continue through there and return via the other wire here, go through into the lamp, and of course that's when it will switch on. And of course when you opened it, then there's no connection here, so although this part here is live, this side is not, and the light no longer works. And at its simplest level, this is essentially how all lights are installed and wired. Now typically the wires here would be in a single cable, and that would normally be the twin and earth variety. So you'd have the two insulated conductors, the blue and the brown, and then the earth would be a bare uninsulated conductor. And for here, then you've really got a couple of options for that. Typically it's going to be that twin and earth type of cable. Now you can buy that with two brown conductors inside, and of course the uninsulated earth as well. And if you can get that, then that's fine, because both of these are live here. There's no neutral at the switch in this arrangement. But what's more commonly used is a piece of the type with the blue and brown inside, simply because it's far more commonly available, and you don't have to buy a special length there. And in the event of this being the blue and brown, of course this piece here, say, would probably be a blue piece. But of course it's not actually blue for neutral, so what you would do at the end here is to place a piece of brown sleeving over it, just to identify that that is in fact a line conductor or switched line, which goes back to the light fitting. And again you would do the same at the end here, inside the ceiling rose itself. Either way is fine. So if you can get the twin brown, then of course that's fine, but in reality most of it is going to be the blue and brown with the ends marked in brown to signify you've got line and switch line. Now this is fairly untidy, but a real ceiling rose of course has terminals inside, which are for all of these various connections here, because of course the neutral doesn't actually come through and straight through to the actual lamp here. There's obviously connections inside, otherwise you'd have to have a ridiculous piece of cable which somehow had branches and things coming out the side of it. So the real kind of ceiling rose looks more like this. Now ceiling roses are typically circular, and inside they have a number of terminals. Now the earth terminal is usually a separate one, just fixed up at the side there. And so these are normally made of plastic, so there's no actual need for this to be connected to earth itself. But you do need a terminal here so you can connect all of the single earth wires together, so that's maintained continuity throughout the rest of the circuit. And then across the centre here, they've generally got a section here for the neutrals, and that will typically have 3 actual terminal holes in it. And all these are connected together. It's just simply a block of brass with some screws fixed in, and that has, say, typically 3. We'll then have another one next to that. Again, that typically has 3 terminals as well. And then over the side here we'll have a 3rd terminal, and that typically only has 2 inside. So these are normally labelled as the earth here. This will be the neutral. This will be called loop, and then this is the line over here. Now the actual lamp which hangs down into the room is connected between the 2 outer terminals usually. So you've got your brown here for the line, that will come down like that, and then of course the neutral as well over here, and that will come down into the room like that as well. So at the bottom here, this is where your light bulb, whatever, will be connected, and that's generally the holder, say, which just hangs down into the room and lights it up. And say these are typically only 2 core. If it was a metal one, then you would simply have an extra earth wire going down to the metal holder. Now in the most basic ceiling rose, you can have 2 cables here, one of which brings the power from the consumer unit, and the other one which goes to the switch, typically on the wall. Now the cable from the consumer unit, again we'll have the 3 conductors inside, and you're going to have the neutral coming in, so that will go to the neutral terminal over here. The incoming line, which will be the brown, will come in, but that will actually go to the centre terminal here. Bearing in mind that if we put that over to the line here, that would result in the light being on permanently and no control over it, so of course that's not what we want at all. And the earth coming in with that cable there simply goes across to the separate terminal there over on the side. So in this situation, neutral again connected straight through to the lamp at the bottom, and that's pretty much what we had on the previous diagram there, just coming straight through to the lamp. Only here we've got a nice connection here, so this obviously is a separate piece of flex, and that's the circuit cabling coming in. Earth here, and then loop here is just separate, and line here is separate as well. So what we now need is the additional cable which goes to the switch. So say put the switch over here. So it's typically going to be on the wall adjacent to the door. And as we saw before, switch is simply an on and off device, so it's got a connection inside, so it's either connected together or not. So the cable from here will actually go over to the actual ceiling rose there in the ceiling, and 3 wires from there again. So we're going to have a brown wire, and we'll put that going over to the centre loop terminal. So now we've got the power coming from the consumer unit and basically going straight through into this terminal and then out to one part of the switch there. And then the other terminal here, which will come out of there, this will actually go back to the light fitting, and that's the one which goes onto the line terminal there. And as I saw before, though this is a blue and brown arrangement, you would typically put the blue with the brown sleeving on at the end, just to identify that that is in fact the switched line. And earth connection, again the same there, it will just go across and connect to whatever terminal is in the switch there, or the metal box or whatever you've actually got over there. So now we've got essentially the same as we had here, though it's much tidier. So power coming in on the line here goes to the centre terminal, and immediately then we can go out to the switch. If the switch is in the closed position, as in on, then power will continue through, come back on this other wire here to the line terminal, and then that goes to the lamp. And then the return path is via the neutral here, which goes back to the neutral block and back to the consumer unit. Now, of course, this is all very well if you only want one light in your house, but the reality is that people have more than one. And for this, we need to continue the power from here to go to another fitting just like this in the next room. And then we can continue on to another and so on until we've put lights in all the rooms of the house. And for this, we need a third cable. So bearing in mind we've got the first cable here, we'll call that cable 1. This cable here, which we'll call cable number 2. And then we need a third one, which we can continue on to the next part of the circuit. So first one we're going to have then is the neutral. So neutral can connect to this spare terminal here, and that can just go over to the next room, wherever that might be. We need the permanent power, so that's the one from the consumer unit. And what a coincidence, there's a empty terminal here just for that purpose, so that will connect in here with the line, and that will go out again to the next fitting. And of course, as before, we're going to have the earth just connected into the earth terminal there, and that goes off to the next fitting as well. And we'll call this cable number 3. So the cables we have is number 1, we can call that power in from the consumer unit. Cable number 2 is for the switch, and that's what we can turn the light on and off with. And then cable number 3 is power out, and that will just go on to the next light fitting. And when you get there, then of course that becomes cable 1 with bringing the power in. You're going to have another switch cable, another light in the room, and another cable going out to the next part of the circuit. And this says the most common arrangement. And if you're going to buy a new light fitting that does not have these terminals inside, before you rip all this down and make a right mess, it's absolutely essential to identify which one of these is the one going to the line terminal here, as in the one that comes from the switch and has not a neutral in, but a line and a switched line. Now in reality, these bits of brown sleeving should exist, but unfortunately in many installations they're simply not there because someone couldn't be bothered to put them in, or say it fell off when you ripped the whole lot down. So before taking one of these down, mark this particular cable here, number 2, in a permanent fashion so you can easily identify which one it is once you've removed all of this stuff. Now this was certainly the most common when people had a single light hanging down inside its room, and of course in many places that's still exactly what you've got. But there are other ways of wiring this, and some of these may be more appropriate if you're going to have, say, multiple lights in the same room, such as downlighters or ceiling recess lamps or whatever you want to call them. And certainly in more modern properties, this type of wiring is becoming less used now, simply for the fact that the days of having a single bulb hanging down in each room are pretty much coming to an end. But the principles are exactly the same. The only real difference is where these 3 wires actually go. Now another way of doing this is, instead of putting all those cables at the light fitting or ceiling rows in the middle of the ceiling, is to put all of those cables at the light switch, and then just have a single cable from the switch to the light in the middle of the room. So as before, we're going to have the cable coming in from our consumer unit, but this time it's actually going to go to the light switch on the wall. I'm going to draw this fairly large in this case. So we're going to have our line coming in, and obviously the neutral as well. And inside here we're going to have the switch just as we did before, so there's our switch with the 2 terminals and the movable contact, of course, between the 2 there, which can obviously connect the 2 together. So the line coming in goes straight onto the switch terminal here, but the neutral there, of course, does not connect to the switch, because if you put the neutral here, when you turn the switch on, you've shorted out the mains, there's going to be a big bang and the switch is going to be destroyed and fuses are going to be blowing and everything else, so obviously the neutral does not connect there. So what you actually need here inside the switch box is a separate terminal, usually with screws or something in, and that's where the neutral goes, so that goes in there. And just before, we of course would have the earth wire coming down again, which will be joined in yet another terminal at the top here. Now from here, of course, we need to get power to the actual light in the middle of the room, so another cable is required. So the line will come out from the bottom of the switch, and that will go to the centre of the room. And we also need the neutral, so that comes from this terminal block here. And of course the earth will do exactly the same, so that will continue up there. And then in the centre of the room here, this is where your light will attach. So you could have a normal ceiling rose, or say a downlight, or any other kind of fitting you wanted. But the upshot is you're going to have your lamp like that there, with the coily filament inside. And the line in neutral, of course, will just go straight in there. And the earth, obviously, if that was necessary to go into the metal case fitting we might have up there on the ceiling. So though this is a different arrangement, it's pretty much the same as we had before. Power coming in here permanently, the neutral goes straight through to the light fitting, earth goes straight through to the light fitting, but the line is interrupted by the switch here, so in this position here it's off, so no connection, so the light's not on. Of course, when it's moved into the closed position, these are joined, and the power goes through to the light, and the light turns on. Now, as before, we're going to want more than one light in our house, so just as with the previous diagram, we can extend all of these wires to another switch in the next room. So here's the other switch in the next room. And all we've got to do again is the 3 cores. So the neutral comes from our neutral connection here, so that will just go straight across. And of course in here we're going to have another terminal block there just for the neutrals. Earth is going to be the same, so again we're going to have a terminal block here for the earth there, or the protector conductor. And again that would come off of the wires here, part of the same cable, and into the top there. And the line, again we can have the switch here just as before. Now the line, it's important to get the correct one here, because we want the one that's coming in from the consumer unit, so the one that's permanently connected to the power. And in that case it's going to be the top one here. So that would come out of there, part of the same cable, and obviously go into the switch there. So here's one cable, there's the other, and that's the third one. So the same 3 cables as we had previously. So 1, 2 and 3, so it's power in, connection to the switch, and power out. The only difference here, we've got power in, going to the lamp here rather than the switch, and of course power out to the next connection, which is the other switch. So all we've done is basically swapped around the light fitting in the ceiling for the switch on the wall. But as before, neutral and earth are basically connected through permanently to all of the devices, and it's only the line that's actually switched here, so that's just broken by the switch there. And again, the same thing would apply at this end. You'd have the earth and neutral going directly to your light in that room, and then the switched line would come out of the switch point here. And just as with the ceiling rows, it's essential to get the cables correctly identified, because if you connect these up incorrectly, then the system's not going to work. And you need to make sure that the cable here, which goes to the light, is of course identified separately from the other two, because these two really are just connected together. Neutral straight through, line straight through there, and the earth straight through. It's only the one going to the light, or the item we're actually turning on off, which has to have the break in it, so we're connecting that to the other terminal of the switch. If you take a switch off like this and get these mixed up, what you can end up with is the power coming in here, stuck on its own, and if you put this one onto here, then when you turn this on and off, it controls the lights in the rest of the house, definitely not what you want. Or if you can get these mixed up the other way around, you may find that the power's on permanently and this light never turns off, and of course there's other undesirable combinations. Now there's a third way of doing this, and essentially it's the same as we've got here, except that instead of having a ceiling rose, you've got a junction box which has the 4 terminals inside, so neutral, loop, line and earth. And generally those are those round brown things with brass terminals inside, which tend to get hidden under floorboards and the like, and that's why that system is really seldom used. Because of course junction box things need to remain accessible, so putting it under the floorboards and putting laminate flooring and tiles over the top really isn't acceptable. But for that particular one, it's exactly the same as this. Instead of having the ceiling rose here, it's the junction box, and then you just have your cable going out to the light fitting in the room below. And unfortunately that was typically done on older systems where you had a ceiling rose, so kind of pointless really, because you're just wasting the terminals you've got in the ceiling rows and just putting an unnecessary junction box in instead. But nevertheless you can still install that if you thought it was necessary. But generally this one with the looping at the switches is far more convenient and certainly avoids the need to have additional boxes and things that you don't want. What you can do, however, is if you've got a system like this and say you're in a loft or something, you want to put say multiple lights in the room, is to replace the ceiling rows with one of those junction boxes, and then you can take out the cable from there to the first light and then just simply loop into the other lights as required. So what you would have there is the cables would go into that junction box, and you would have your junction box there with your cables coming in from the consumer unit. Cable would go out to the rest of the circuit, and you'd have your cable here to the switch. And then the wires that come out for the actual ceiling rose where the lamp would be fitted, you're going to have your line, neutral and earth, and you can go to your first light and then simply connect into the second one and into the third one. And then of course the same with the neutral as well. And again with the earth also. And that would be commonly used, say, with multiple lights in the room, so you'd have one downlighter here, another one here, and a third one there, and in fact as many as you actually wanted. So then they'll all just turn on at the same time. So that's a look at the basics of a lighting circuit. Next time we'll have a look at switches, and in particular how you can have 2 or more switches controlling the same light. And that's something which is fairly common in things like stairways and other like long hallways and the like. So until next time, thanks for watching.